Hello! You've decided to take Calculus 12. Good job! You've made it. This year in Calculus, you're going to learn lots of things about lots of things, such as, I don't know. You'll learn things. Here are some examples.
The first example of why you should take calculus occurs in the classroom. You can make great friends.
So as you can see, the discontinuous integrable functions are really good.
Derivatives are great, man.
I know, I love doing them. This is so much fun, buddy.
Thanks, man.
I know.
Hey, Josh, how's it going?
Oh, what's up, Evan?
Another example happens in the classroom as well, and that is that your friends will always support you.
So as you see right here, 200 plus this thing is then dc over dx.
Oh! I got it! I know! Equals the big fish!
The last example that occurs in the classroom is that you always have great teachers who will help you, especially when it counts.
Shown here, pain reliever, acetaminophen. In large doses, it's toxic. Don't eat it.
Oh, yeah, okay.
To calculate the dosage, we use calculus.
In calculus, we learn many real-life examples that can be applicable in everyday life, such as instantaneous speed while running. Another real-world example we learn is that when an object is thrown and reaches the top of its arc, its movement is equal to 0. Wow!
Okay, you have an apple there. You're gonna throw it.
Okay.
When it gets to the top of this thing, if it's arc, the derivative is 0. There's no derivative.
Wait, I gotta test this.
As you can see, kids, this is the graph of what's happening with the apple. When it reaches the top of its arc, the derivative is equal to 0. There's no derivative! Lesson's over.
In another real-world example, we learn how to optimize the perfect volume for a box. Wow! Amazing!
I finally found the perfect optimization for the volume of my box! It's perfect! It's perfect! Wow!
In this last real-world example, we learned the rate at which a pool can be filled. Stupendous!
With related rates, I can figure out how fast I need to fill my pool.
Using calculus, engineers can learn how to build a bridge. Great!
Another job that uses calculus is an accountant. Accountants can use calculus for such things as calculating interest.
Using calculus, programmers can program complex 3D images. Amazing, right?
She's up all night to the sun. I'm up all night to get some. She's up all night for good fun. I'm up all night to get lucky. We're up all night to...
Surprisingly, calculus teachers teach calculus every day. And guess what?
They use calculus!
Here's a little bit more of a complicated one when we don't just have a constant, we actually have some variables involved. We're going to go ahead and plug that in, but hold on now, we can't just plug it in. We can't just plug that in for where x is.
Newton actually discovered calculus between 1665 and 1667. He was only 22 at that time, and he preferred not to publish his discoveries. Newton is known for creating Newton's method for approximating the root for a differentiable function, but Newton is best known for his work in physics, and especially his 3 laws of motion. Leibniz discovered calculus about 8 years after Newton, but he was very open with his findings. This led to a feud between Newton and Leibniz, now known as the Great Sulk. Not only was Leibniz a great mathematician, he was also a philosopher, scientist, diplomat, and a lawyer. Leibniz is well known for introducing notations that are still used in calculus today, such as the dy over dx symbol and the integral symbol. It is even attributed to him that the equal sign is used throughout the world. It is hard to believe that a man with 13 children, who went blind for the last 17 years of his life, was able to publish, on average, about 800 pages a year throughout his life. Euler managed, with writers to help him, to publish even more work after going blind. Euler contributed to every branch of pure and applied mathematics and even discovered some new ones. It has been said that any elementary or advanced calculus text printed after 1748 is basically a copy or a copy of Euler's work. Thanks to Euler, we have symbols for pi and e. He also did extensive work on infinite series.